Well, grade 9s, welcome to another lesson. And here, let me get rid of this weird thing you're seeing here. Um, yeah, listen, we've been talking about refraction. Okay, and refraction is when light bends when it enters glass. Well, you know, you give that to an engineer, and what can you do with it, right? Well, you can actually construct something called a lens. And the lens uses the fact that light bends when it enters in glass. And we can use that to do numerous things like construct a telescope or a microscope or a pair of glasses that you can wear to correct vision problems. And I mean, those of you who wear glasses, and like I gotta admit that I used to be one of them, okay, before I had laser eye surgery. Yeah, without glasses, a world without glasses would be not a good place for people who wear them. Okay. I mean, some people are, almost blind without them when you think about it. And so, it depends. But like, I mean, I know that for me, I only had a mild prescription, but it was very important when I was at university that I had a pair of glasses just to see the board. So, yeah, anyway, glasses and various other applications. Like I said, telescopes, microscopes. We're going to look at that today. Okay. Don't forget you have a quiz on mirrors on... okay, wait. You are cohort A, I think. Okay. So you have a quiz next time I see you, which would be Thursday. Okay. That's on mirrors on Thursday. We're going to do a lab on lenses as well. And then we're going to have a test the following week as well, okay, on everything else. Okay, now I don't know how far we're going to get with this. It was kind of a bonus anyway, so I don't know if we'll get, to do the eye and some of the other things that we wanted to do, but we'll see what we can do. Okay, but next Wednesday, I think I see you next after Thursday. And so almost a week later, okay, you'll have another test. And that will wrap up the course, guys. So, yeah, getting close to the end. All right, so let's talk about lenses. And here you can see I've got another gizmo on the screen. And everyone's favorite, these gizmos, right? I think it's kind of neat. It takes you through the process, right? And it shows you how things work. So if you remember with mirrors follow basic rules, okay, that we can use to locate an image and stuff like that. So here it's very similar. I have a lens. Now this is a convex lens. Remember concave and convex, right? So convex lens versus a concave lens. Now remember a concave mirror actually looks kind of like that. It's caved in, okay, at the center. And that's how I remember it, concave versus sort of the, this sort of hourglass figure, okay, versus the convex lens, which is kind of round in the center. It's widest in the middle. So we also have convex lenses, okay, and convex and concave lenses as well. So there's both types of lenses, just like there are both types of mirrors. And the rules are actually quite similar. The only difference with a lens is that the light doesn't reflect off of the lens. It goes through. It refracts, okay? So let's take a look at the rules, okay, on how you draw ray diagrams. We're going to do with mirrors what we did with, lenses what we did with mirrors, which is we're going to first look at how to draw the ray diagrams, and then we're going to look at the thin lens equation it's called. I think you're going to recognize it. I think you are, okay? When we go through it, you'll see what I mean. All right, so I just want to take you through the rules, and then I have a little gizmo sheet for you to do. It's online. I suggest you print it out before we go ahead and do it. Okay, but rule number 1. Okay, now remember, rule number 1 for mirrors was a ray parallel to the principal axis, and here we see the principal axis as it was before, and there are actually 2 focal points. A mirror only has 1 focal point, okay, but a lens has a focal point. It's kind of symmetric. It has one on either side, okay? So if you remember rule number 1 for mirrors, a ray that's parallel to the principal axis, remember you have a test on this on Thursday, right? A ray parallel to the principal axis reflects, so it goes through the focal point. Well, rule number 1 for lenses, a convex lens, is very similar. Whoops. A ray that's parallel to the principal axis goes through the focal point. It's very much the same rule. Okay. The only difference is, okay, now I'm just going to see if I can fix this a little. Yeah. Okay, so a ray that's parallel to the principal axis goes through the focal point. The only difference is the focal point is actually behind the lens. And we do expect the light to go through the lens. After all, it's a piece of glass. So it will go through the lens. It could not reflect into the focal point in front of the lens. It never does that. It goes through. But it's a similar rule. A ray parallel to the principal axis, so here's our ray parallel to the principal axis, refracts through the focal point. Now, when we're doing this on paper, I would expect you to draw the line all the way up to this dotted line where the vertex of or we call it the optical center of the lens is here, and then just refract it from there. All right, so that's rule number 1. Rule number 2. It's kind of, remember for mirrors, rule number 2 was a ray through the focal point reflects parallel to the principal axis. We'll look at rule number 2 here. So a ray through the focal point in front of the lens refracts parallel to the principal axis. And here we see where these two rays meet. Here we get our little image of the candle forming. Okay, so that's the image on this side. It's a real image. The reason why it's a real image is because the light really goes there. Unlike a mirror, where when it was behind the mirror, the light doesn't actually come from behind the mirror. So there's no real image back there. In this case, there is a real image there. If I were to put a screen in this location, I could see the image of the candle. In fact, we're going to do a lab like that on Thursday, okay, with the candles, as promised. Get to play with fire, right? All right, so that is rule number 1 and rule number 2. Notice how they're very, very similar to how it works the same way with mirrors. Okay, very similar rules. Slightly different because they go through the lens, they don't bounce off, but really, virtually, it's the same rule. Now, there's a third rule. Okay, now with mirrors, the third rule was a ray that goes through 2F just bounces straight back. Well, this rule is completely different this time. It's not the same rule at all. Here, a ray that goes through the optical center just keeps going straight through. Okay, so that is a completely different rule from what our third rule was with mirrors, but whatever. Okay, there's your 3 rules. And as you can see, the 3 rays meet. They must meet at the same spot, and here is where we get our image being formed. Now, this is a real image. It's inverted, and it's smaller, and it's located about, looks like about 16, 17 centimeters from the lens, from the optical center where the origin is. Now I can move this object around, and you can see that the image moves around too. Okay, notice how it's getting bigger and bigger and bigger. Still a real image. It's still inverted. Okay, and if I were to go right on the focal point, just like the mirror, right at the focal point, you get no image. Okay, and that was very similar to the situation that we got with a concave mirror. Now, if I bring it even closer, we start getting a virtual image. Now, can I make this smaller? Oh, there it is. Okay, there's our virtual image. So what happens is, if the image is on the same side, okay, as the object, it's kind of the opposite of mirrors, right? So if it's on the same side as the object with mirrors, it was real, but now it's virtual. That's actually a virtual image. If I put a screen here, the light actually doesn't travel there. The light only travels to the opposite side of the lens. But the virtual rays, okay, they intersect here, and what you would have to do is look through the lens with your eye on this side, looking through it, and you'd see the magnified view of the candle. So this is how magnifying glasses work, right? This is exactly what we do with magnifying glasses. All right, so that's it for this. Okay, now you understand the convex lens, and that's all I'd like you to do today. So here, let's go to OneNote. Here we have this ray tracing activity with Gizmos. So again, use the student logins that I gave you before. The purpose is to sort of get some working understanding of how convex lenses work. Okay, so here, I'm going to ask you to try to answer these questions. Okay, it says here, why is a convex lens used for starting fires? Can I just tell you that parallel rays will focus like at the focal point? So because that focal point works that way, the light actually converges on the focal point, and you can, like, say, burn a hole in a piece of paper or something like that. See, that's what convex lenses are for. They're magnifying glasses. Now, we'll go ahead and I'll just take you through some of the steps here. Okay, I've already introduced you to the app, so I did the warm-up with you already. Okay, you can just follow these instructions, it's no problem. Okay, and let me see where I want you to end this. Okay, I need you to fill in this table, that's for sure. All right, so what I would like you to do, doesn't that not look almost identical to what we did with mirrors? Okay, in fact, you'll see it's basically the same. All right, so what I would like you to do is we're going to end this right here. So I'm going to put a yellow line. Okay, stop here if you're working online tomorrow, or sorry, I'm recording this the night before, so please stop there, and that's where I'd like you to end. Now once you've done that, once you've done the gizmo, you should be able to, going back to OneNote, I made some, well no, just leave it, that's good enough for your lesson. Okay, and our last test next week will be on lenses and refraction, so we'll do that. So we'll do a lesson on Friday, and then we'll have a little quiz next week. You'll have about a week to get ready for it, and we'll do a little quiz. Don't forget, very important, to bring me back your textbooks. You don't need the grade 11 textbooks anymore. I thought we might use them for this, but I changed my mind. I'm just giving you lots of handouts. So bring in the textbooks, please, if you still have one, and I'll mark your name off. I absolutely need those before the end of the quadmester, so that means next Wednesday at the latest, and please don't make me chase you for that. That's very frustrating for me. Okay, so please bring in the grade 11 physics textbooks on Thursday, please. Okay. All right, guys, that's it for today. So just go ahead and do this gizmo up to the yellow line. You should be able to do it, and that's it. The gizmo is basically a virtual lab. That's why I like you to do it. I like you to sort of see it and understand how lenses work, and I'm hoping it's better than me just telling you. Okay, so anyway, give it a shot, and we will take it up on Thursday after your quiz. Quiz won't take very long, and then we'll go ahead, look at lenses, and we'll wrap up the course pretty much. All right, guys, have a good one. We'll talk to you soon.